Hello students, in this class we will learn how we can factorize cubic or mode degree polynomial with the help of finding its zeros and then using factor theorem. Okay, so there are two problems. They are x cube minus 6x square plus 3x plus 10 and 2x cube minus 5x square minus 19x plus 42. So we have to factorize these two cubic polynomials. So when we want to factorize these cubic polynomials, first of all we have to find minimum one of its zero. Okay, then we can use factor theorem, and after finding its one of the factor we can use division algorithm. Okay, which will give more factors. Solution 1. So first of all, we let this polynomial as f of x. So f of x equals to x cube minus 6x square plus 3x plus 10. So to find one of its zero, we can use integral root theorem, as the coefficient of the leading term is 1. Okay, and here the leading term is x cube whose coefficient is 1. So we already learned about integral root theorem and rational root theorem to find the zeros of a polynomial. So here the coefficient of this leading term is 1. So here the leading term is x cube whose coefficient is 1. So we can use integral root theorem to find the zero of this polynomial. The constant term equals to 10. Factors of constant term are plus minus 1, plus minus 2, plus minus 5 and plus minus 10. F of minus 1 is equals to minus 1 whole cube minus 6 into minus 1 whole square plus 3 into minus 1 plus 10 equals to minus 1 minus 6 into plus 1 plus minus 3 plus 10. This will give minus 1 minus 6 minus 3 plus 10. This will give minus 10 plus 10 equals to 0. Therefore, imply minus 1 is a 0 of the polynomial f of x. So therefore, by the factor theorem, we can say that x minus of minus 1, that is x plus 1, is a factor of the polynomial f of x. Okay. So this is the way by which we can find one of its factor. Here we will choose those values of these factors which will give 0. Okay. So here f of minus 1 equals to 0. That is why minus 1 becomes a 0 of this polynomial, and by factor theorem we get x plus 1 is one of the factor of this polynomial f of x. Okay. Now we have to divide this polynomial f of x by x plus 1 by the long division method. So to get x cube, we have to multiply this x by x square, because x into x square will give x cube. So in the quotient there will be x square. So after multiplying we have x cube plus x square, and after subtracting we have plus minus minus plus minus minus. We can easily cancel these two x cubes, and minus 6x square will give minus 7x square plus 3x plus 10. So to get minus 7x square, we have to multiply this x by minus 7x. So x into minus 7x is minus 7x square. So in the quotient there will be minus 7x. So minus 7x square plus minus minus 7x. After subtracting we have plus 7x square plus 7x. So after cancelling 7x squares, we have 10x plus 10. Now to get 10x, we have to multiply this x by 10. So x into 10 will give 10x. So in the quotient there will be plus 10. So after multiplying with x, we have 10x plus 1 into plus 10 will give plus 10. After subtracting, we have minus 10x minus 10. We can cancel these two, and 0 becomes the remainder. So therefore, f of x becomes, f of x equals to x plus 1 into x square minus 7x plus 10. So this part of this factorization becomes the quadratic part, and we can easily apply middle term factorization to find more factors. So we have to bring 7 by the addition or subtraction of two numbers. For this we have to multiply the square term, that is 1, with the constant term, that is 10. So 1 into 10 will give 10, and two factors of 10 are 2 and 5, whose sum will give 7. So 2 plus 5 equals to 7. So x square minus 5 plus minus of 5 plus 2 into x plus 10. So x plus 1, x square minus 5x minus 2x plus 10. From these we have two terms, we have x as a common factor. So this becomes x into x minus 5, and for this last two term, minus 2 becomes a common factor. So minus 2 into x minus 2 into minus 5 will give plus 10. So this is minus 5. X plus 1 whole into x minus 5, and the rest of the term becomes x minus 2. So this is the product form of these three factors of this cubic polynomial f of x. Okay. So thus we can represent this polynomial f of x by the product form of these three factors. So this is the required factorization. So in solution 2, we have to factorize 2x cube minus so here we have to factorize 2x cube minus 5x square minus 19x plus 42. That is why first of all we let f of x equals to 2x cube minus 5x square minus 19x plus 42. Here the leading term is 2x cube, whose coefficient is 2, not equals to 1. So we can apply rational root theorem to find its zeros. Factors of the constant term (42) are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 7. Continuing, which represents B, and factors of the coefficient of the leading term two are plus minus 1 plus minus 2, which represents C. Okay, so already we know rational root theorem. So by rational root theorem, we have to find the zero of this polynomial f of x. Okay, so to use rational root theorem, we have to find first of all the factors of the constant term, and here the constant term is 42, whose factors are plus minus 1 plus minus 2 plus minus 3 plus minus 6 plus minus 7 continuing. There are so many factors of 42 which are also represented by the letter B, and factors of the coefficient of the leading term, that is 2, are plus minus 1 and plus minus 2, which represents C. Now, B by C are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 7, and continuing. There are so many values of B by C. We have to choose one or more values of B by C, which will give the zero of this polynomial f of x. Okay. F of 2 16 minus 20 minus 38 plus 42. This will give 58 minus 58, gives 0. So, this implies 2 is a 0 of the polynomial f of x. Okay. So, by factor theorem, we get x minus 2 is a factor of the polynomial f of x. Now, we will use long division method to find more factor of this polynomial f of x. So, to get 2x cube, we have to multiply this x by 2x square. In the quotient, there will be 2x square. After multiplying with x minus 2, we get 2x cube minus 4x square. And after subtracting, we have minus 2x cube plus 4x square. Cancelling these 2x cubes, we have minus 5x square plus 4x square will give minus x square minus 19x plus 42. So now to get minus x square, we have to multiply this x by minus x. So x into minus x will give minus x square. So in the quotient there will be minus x square. This is minus 2 into minus x will give plus 2x. After subtracting we have plus x square minus 2x. Cancelling this x squares, we have minus 19x minus 2x, that is minus 21x plus 42. Now to get minus 21x, we have to multiply this x by minus 21. X into minus 21 will give minus 21x. This is minus 21x plus 42. After subtracting, we have plus 21x minus 42. Cancelling these two, we get 0 as the remainder. Therefore, f of x becomes x minus 2 into 2x square minus x minus 21. Okay. Now we can easily factorize this now we can easily factorize this quadratic polynomial by following middle term factorization. Here the linear term is minus x. Excluding its sign, its coefficient becomes 1. So to get 1, first of all we have to multiply the coefficient of the square term, that is 2, by the constant term, that is 21, excluding its sign. Coefficient of the square term is 2 and the constant term is 21 excluding its sign. The product becomes 42. Its two factors are 6 and 7, because 7 minus 6 will give 1 and we required 1, which is the coefficient of the linear term x. So this becomes 2x square minus of 7 minus 6 whole into x minus 21. X minus 2, 2x square minus 7x plus 6x minus 21. By these first two terms, x is the common factor. So after taking out x as a common factor, we have 2x minus 7 as the rest of the term. And for this last two part, 3 is the common factor, plus 3. After taking out plus 3 as a common factor, we have 2x minus 7 as the rest of the term. Thus it becomes x minus 2 into 2x minus 7 is the common factor for this part. So 2x minus part, when we are taking out, then the rest of the term will be x plus 3. So we can represent f of x by the product of these three factors, x minus 2, 2x minus 7 and x plus 3. Okay, thus our factorization complete. So this is the required factorization. So in these two problems, we learn to factorize a cubic or mode degree polynomial. First of all, we have to find its one of its 0 by using integral root theorem or rational root theorem, and then after finding one of its 0, we can easily use factor theorem, and by applying factor theorem we will get one of its factor. Okay, when we get one of its factor, then by long division method we can easily find its other factors. Okay, so for these cubic polynomials, the other factors will be a quadratic polynomial. Then we can multiply that polynomial f of x by the product of a linear and a quadratic polynomial. And we already know how we can factorize a quadratic polynomial by middle term factorization. Then after finding all the factors, we can easily represent a given polynomial, say cubic or quadratic, by cubic or by quadratic, by the product of its maximum number of factors, and thus our factorization is completed. Okay.